How do we solve trig equations? Like so. This is asking the sine of what angle equals radical 3 over 2. There are many such solutions, because if you look at the sine curve, here's sine x, and it goes on forever. Radical 3 over 2 is in here someplace. You see you have a whole lot of answers. How do you generate all of these answers? Well, you need a reference angle. The first thing that you need to know your 30, 60, 90 triangle and the 45, 45, 90 triangle. The 30, 60, 90 has a radical 3 in it. The ratios of the sides are 2, 1, radical 3, your 30 and 60. So right away, you can see that one of these, so you look at these and say, which of these angles has the opposite side to the hypotenuse in a ratio of radical 3 over 2? The answer is 60 degrees, pi over 3. And that's one of the answers. So pi over 3 is one answer. Additionally, if you take pi over 3 and you add 2 pi to it, you also get more coterminal angles, and they are also answers. So one set of the solutions would be pi over 3 plus 2 pi n, where n being an integer, and if n is 0, you get the angle itself. If n is 1, you get this plus another revolution. If n is 2, you get another revolution, and so on and so forth. So this is half of the answers. But there is another angle inside here that has a sine of radical 3 over 2. If you look back at the graph here, in the full rotation from 0 to 2 pi, we have two answers. This one looking like it's in the second quadrant. You know that the reference angle has to be 60 degrees. So you're going to think, where else, in which other quadrant is sine positive? Sine's going to be positive in this quadrant and in this quadrant because it's based off the opposite side, the vertical side of the triangle. So it's going to end up being in here with a reference angle of 60 degrees, pi over 3. So what is that? Well, that's actually 2 pi over 3 is the answer, right? 2, 1, radical 3. Opposite to hypotenuse is radical 3 over 2. So the other answer is 2 pi over 3 plus 2 pi n, similar to the other one. So the complete set would be pi over 3 plus 2 pi n in addition to the other one. The one set, if you look back at the graph, this one here, that would be this number here, add 2 pi, you get this number, add 2 pi, you get that number, and so on and so forth. And the 2 pi over 3 are all the other ones. They're all solved exactly the same way. Cosine theta equals minus 1/2. You think, which triangle do you have to reference? You go for the 30, 60, 90 again. So 2, 1, radical 3. Which of these angles has adjacent to hypotenuse? Again, it's 60 degrees. But it also says cosine is negative. So you think, in which two quadrants is cosine negative? Since cosine is based off of the horizontal side of the triangle, it's going to be negative in the second and third quadrants, with a reference angle of 60 degrees. So 60 degrees, so again, that's the first solution is 2 pi over 3 plus 2 pi n, count for all the rotations. And this one down here, again, with the reference angle of pi over 3, the total angle is 3 pi over 3, which is 180, plus the additional pi over 3, so that's 4 pi over 3, plus 2 pi n. No other angle between 0 and 360 has a cosine of minus 1/2, so this is the set of all the solutions. Or something like this, sine 3x. It's a little more complicated, but not so much. You need to know which triangle to reference. Let's go with 30, 60, 90 again. 2, 1, radical 3. It does not appear that there is a side, the opposite to the hypotenuse, are ever in a ratio of 1 to radical 2. So we went with the wrong triangle. So in that case, you go for the 45, 45, 90. Those sides are 1, 1, radical 2. And that will do it. You see that the angle here, 45 degrees, pi over 4 in radians. The sine is 1 over radical 2. So we got it. So then you ask, well, what significance does that 3 have? Well, it's really not all that much more complicated. Let's just get the base answers first. Let's assume, or pretend that the original question was sine of just x equals 1 over x. So we'll solve that. This is the one that we're going to go for. So you think, all right, sine is positive. In which two quadrants is sine positive? We just did it. It's positive in the first and second. The angles that have a reference angle of 45 have a sine of this. So we'll draw 45. That's one solution. So the answer is pi over 4 plus 2 pi n. And the angle in this second quadrant with a reference of 45 degrees. So that's actually 3 pi over 4. Right? Opposite hypotenuse. 3 pi over 4 plus 2 pi n. Now, these are x values in this, right? We want the argument of the sine function to be these numbers. If the argument is these numbers, then we're all set. Well, this isn't a whole lot different. Instead of wanting x to be these numbers and these numbers, we want 3x to be those numbers. And the final solution of these would be, you just set the argument equal to whatever the answers are, and then you solve for x by dividing. So the final answers would be x equals pi over 12 plus 2 pi n over 3. Don't forget to, when you divide by 3, you have to apply it to both pieces of the answer. Otherwise, it's incorrect. X equals pi over 4 plus 2 pi n over